Okay, guys, so we're going to go through Dijkstra's algorithm. It's not necessarily something that we covered explicitly in class. However, we will go through, as I have seen it in your Saxon exams before. But in any case, if you're able to, at the very least, do shortest paths using inspection, you don't have to learn Dijkstra's. It's just good to know, good to have in case it does pop up. Okay, it is confusing, so make sure you follow along with me. Now, the good thing with Dijkstra's algorithm is it actually gives you the path from any vertex, well, from a listed vertex, in this case, from X to any other vertex, and it gives you the shortest path to those vertices. So basically, if to put it in a nutshell, the Dijkstra's algorithm helps you to find the shortest path from one vertex to every other vertex. Okay. So in this case, we're trying to get from X to Y, and what's the shortest path for it? Now you can go ahead and use your trial and error method to find the shortest path. However, Dijkstra's, like I said, is something that I have seen in the SACs before and in the exams, so just make sure we understand it. So when we do Dijkstra's method, always start off by drawing a table with two columns. Okay, like so. And on the left side, I like to write from and then vertex X to every other vertex here, okay? And then on the second column will be distance. Okay, so let's write down all the vertices. So you've got vertex X, A, B, C, D, E, F, G, H, I, and then Y. Okay, so we're now on this table that I've drawn. We need to list down the distance from a vertex X to every other vertex. Okay, so from X to X, okay, you're going to write 0. Why is that? Well, because from X to X, you haven't traveled anywhere. Okay, so the distance has to be 0. Easy. Okay, and I also like to put in brackets what was the previous vertex. So the previous vertex from X to X is whatever the from was, which is X. Okay. I know that this might seem a bit redundant and pointless, but just bear with me so you can see the pattern and how it works. The next one is from X to A and also X to C. Okay, so you've got to write down the distance for those two values. So from X to A, okay, I can see the value was 2. Okay, and then X to C, so I can see here X is directly connected to C. The value was 3. So in brackets, the bracket in brackets, remember, it's the vertex before that one. So 3. Okay, what's next? So I need to travel to B. So from X to B, what's the shortest distance? I can see I can go through A. So I've already got the distance of 2 when I get to A. And then from there, A to B, I just got to add 5 because, remember, from X to A, I've already done 2. Okay, so then from A to B, I just add 5. So 2 plus 5 is 7. The previous vertex was A. Okay, if there's any shorter ones, we'll update this and also this. But for now, let's leave it at that. Okay, now to D, shortest distance to D. Well, I can go from X to C, which is 3. And then to D, it will give you 7. Okay, so you can see from C right there, there's already a distance of 3. And then to get to D, I have to add 4, which is going to be 7. Okay, and the previous one was C. However, there's probably a shorter one, and this is where it does get annoying because you do need to update the distances depending if you find shorter ones. So I can see that to get to D, it's actually quicker if I go from A. All right, you can see A already has a distance of 2. So A to D has a distance of 3. Therefore, 2 plus 3 will give you a distance of 5. So that's a lot quicker than 7. Hence why I've changed it. Cool. Now let's go to E. So what's the quickest way to get to E? I can go from X to A to B, and that's already given me a value of 7. So if I add another 2 from B to E, I'll get 9. Okay, so let's put that in. However, are there any other quicker ways? Well, let's have a look. x to a to d already gives me 5, right? See there. And if I add another 3, it will give me 8. So that's actually better to go from x to a to d, because the distance from d to e is is 3, and that'll equate to 8. So let's change this to d. Okay, cool. Where else I need to go? Okay, f. How about x to f? What's the quickest way from x to f? So I can go x to a to d, which gives you 5, and then from there I can go and add another 5, right? So there's 5 from x to d, and then add another 5 to get to f, and that'll give you 10. And the previous vertex was d. Are there any other ones? In this case, I don't think so, but you can check if you want to. You can go that way, then E, but then you'll be adding extra vertices and distances, so there's no point. Okay, so to F, that's the quickest way. All right, now we're up to G. What's the quickest way to get to G? Well, I've got two options, yeah? I can go from E. Okay, so from E, I can see the distance is already 8, and I can add 6 to get to G. Or I can go from F, and I can see the F. To get to F, the distance is already 10. Okay, and you have to add another 6 to get to G. So it's actually better to go from E, because you're only at 8. Okay, when you're at that point to E, and then you only have to add another 6. So 8 plus 6 gives you 14, which is better than going this way from F, because that will give you, what's that? 5 plus 10. 5 is 10, plus another 6 is 16. Okay, so it's higher than this path so far. Okay, where are we at now? H. Okay, hopefully now you're kind of seeing the pattern here, and that you're understanding what you need to do. So H. Okay, I want to get to H. Well, I've got an option. I only have really one option, which is to go from G. Okay, and the distance is only 1. So to get to H, the previous is G, and G, remember, had a distance of 14. So to get to here from X is 14 already. So I just need to add 1 to get to H. Right, 1, the distance there. So it's going to be 15. Okay. And now to I. Well, from I can go from G. Okay, because it's quicker than obviously going from H. So because when I'm up G, okay, I've got a distance of 14 already from X. So I just need to add an extra 3. So 14 plus 3 is 17. And I came from G. There. Okay, last one. Okay, we now need to get to Y. Now I can see from Y, I can either come from H or I can come from I. Okay, I can see that because you've got these two vertices there that connect to Y. So which one is better? Well, let's have a look. If I come from H, it's 15 already, plus the 4. So that'll give me 19. But if I come from okay, it's 17. It's already 17 at this point, and I just need to add another 2, which is there. So it's also 19. So at the end of the day, it doesn't really matter if you come from I or H in the end. So what happens now? Okay, I've completed my table, and I can see the distance, the shortest distance from X to every other vertex. Okay, so from X to B, the quickest distance or the shortest distance is 7. From X to E, the shortest distance is 8. X to F, the shortest distance is 10, so on and so forth. But the trick now is, and the reason why we have this, is it will tell us the actual path or the route to get those distances. So remember, the initial question was, what is the shortest distance or shortest path, sorry guys, from X to Y? Okay, so from X to Y. Now, according to this, the shortest distance is 19. How do we get 19? Okay, so this is where it gets a bit annoying, but also quite interesting. So let's write down the path, but backwards. So starting from Y, what was the previous vertex? We actually use another color. Starting from Y, What was the previous vertex? Well, I can see was H. Okay, so let's go to H. What was before H? Well, it's G. Okay, so before H was G. And what was before G? Well, it was E. Okay, so E. And what was before E? D. And what was before D? You had A. Before A, you had X. There. Okay, and there is the root for it. And you can actually test it if you want. X to A is a distance of 2, plus A to D is going to be a distance of 3. So I've got X to A, and then A to D is a distance of 3. D to E is 3. And then E to G is 6. And then G to H is 1. And then H to Y is 4. So if I add all these up, it should equal 19. So let's double check that. 2 plus 3 plus 3 plus 6 plus 1 plus 4 equals 19. Okay, so we got it right. And that is how we do Dijkstra's algorithm. I hope it's made sense. I might link other videos that could be better in explaining this. But yeah, just make sure you understand how to derive Dijkstra's algorithm and using that to find the shortest distance from one vertex to every other vertex. Thank you.